Morning. Today's the final day for our week-long lecture series, which is an extension of Judy Rubio's solo exhibition and an extension of the Winter Institute. Our final guest speaker today is Dr. Harinder Aujla, whose lecture is titled Computational Approaches to Understanding Language. Before I go ahead into today's program, I would like to spend some time to give my respects and reverence to the First Nations peoples whose resources and land I live on and work today. We're on Treaty 1 territory. It's a territory belonging to a diverse range of Indigenous communities who've been stewards of these lands for many, many centuries before colonial contact and recorded history. Some of these communities include the Anishinaabe, the Ojibwe, Dakota, the Dene peoples, as well as the national homeland for the Red River Métis. So as I mentioned, Dr. Aujla will be giving a talk today, and this talk is going to be focusing on how language usage reflects and shapes our human experience. With the advent of computational techniques such as vector space models and neural network-based large language models, LLMs, in conjunction with the proliferation of information available on the internet, has provided new opportunities to examine language on a larger scale. Dr. Aujla will present approaches to extract both meaning and sentiment from online text sources and provide some examples of how this information can be used to help understand communication. Dr. Aujla is a professor of the Department of Psychology at the University of Winnipeg. He uses computational models of semantics to understand how different groups of people come to have different understanding of the same words. Please help me welcome Dr. Aujla to the stage.
Good, thank you. Great, thanks so much for the introduction and for inviting me. Today to kind of share some of the ideas with respect to computational approaches to language. And is this working? Oh, sure. Okay. So I want to talk about computational approaches to understanding language. I just got a lot louder speaking of language. And I'd like to just start with an example. This is just an arbitrary example that I picked, the word freedom. And I picked freedom because freedom is an abstract word, right? It's not something that is tangible. We can't touch or feel or taste freedom, although we can experience things that are related to the word freedom. So when people think of the word freedom, I assume that what comes to mind isn't literally just the word freedom, like floating around in your mind. It's other things. You might imagine like voting, for example. You might imagine, some people might imagine a flag that represents freedom to them. Some people might imagine a resistance movement. There are different ways to think about this word. Everyone knows what the word freedom is, but I don't think most people know the word freedom because they looked it up in a dictionary. People don't say, well, how do I know words? Well, I looked all of them up in a dictionary and that's my vocabulary. Our vocabulary is built on experience. If I were to go through a book and cross out all instances of the word happy and replace them with blue bloob, you'd figure it out, right? You know, Jim won the lottery, he felt blue bloob, right? Someone got promoted at work, they felt blue bloob. You'd be like, oh yeah, they're happy. That's what blue bloob means, it means happiness. And so it's the context, it's the other words that tell you what that word means. We can take that to its logical kind of conclusion and say, well, that could work for all words, right? Why can't we just simply have the shared context of words kind of directing their meaning? And so this idea is not new, and it's also not mine. It was proposed by Firth and probably thought of before Firth, who worked in the 30s, 40s, and 50s, a linguist. And he said, "You shall know a word by the company it keeps." I think a very succinct kind of summary of that idea. The context or the other words that appear, for example, in a sentence or paragraph tell you what a word means. The idea of freedom, I also picked freedom because it's a word that generates conflict, right? In the sense that people don't agree on what freedom means, right? So if we think about the convoy protest in Ottawa, I think you had people that had a very different sense of what freedom meant in that context. Right? For some people, they had freedom. Other people felt they were being deprived of freedom, and it kind of cuts both ways. And I'm going to propose here that our experience with language, in part, informs our ideas of what these words are, but also we don't all have the same experience with language. And because we don't all have the same experience with language, we don't necessarily have shared meanings of words. So it's not just that people that we don't agree with talk about different things than us. They may talk about the same things superficially, but they're still talking about different things than we might be talking about. Okay, so discourse analysis is this kind of broad area and defined as language usage beyond the sentence. So taking into consideration that different groups of people will understand words differently is part of discourse analysis. And that's what I'd like to focus on, how different groups of people are going to understand or represent words differently in terms of their meaning. A computational approach can help us in this regard. You could imagine that you could say, well, I could read sources of text generated by different groups of people and try to come to understand how they use language. But that becomes very labor intensive very quickly. There's a limit to how much a person can read, right? And if I want to compare a lot of different groups, there's also a limit to, that's going to compound the problem. And of course, the further complication is, as a person, I'm coming into the situation with my own language meaning. So I'm now going to be biased regardless of who I am based on my own experience with language. So computational approaches allow us to kind of examine or extract meaning from words in large quantities of words. And now with the internet, we have all kinds of sources of language. We have billions, if not trillions of words that we can now sort of look at in context. And we can also select words or select language from certain groups of people because they're publishing or disseminating that knowledge in particular types of venues. Okay, so that's fine. We want our computer to tell us something about words, about language usage. And we also want that kind of language usage, again, to be spread out over a large quantity of language. But how does a computer actually represent a word, right? So that's our first problem. We need the computer to somehow internally be able to represent a word. And because I'm a psychologist, preferably in a way analogous to how a person does it. It's always kind of the goal of a psychologist. And the second thing is I talked about how our language experience shapes our meaning or definitions of words. So each time we hear sentences, as we kind of grow and acquire language, can we simulate that process in a computer? Can the computer kind of start off from a place where it doesn't know any words and then gradually come to acquire the meanings of words? So those are two kinds of essential things that we'd like our computer to do. Semantics is just the meaning of words. That's what semantics means. And so a semantic space is literally that. It's a space in which words with similar meaning are close together and words with different meanings are further apart. Okay, and if I'm going to be more precise about this, I guess I would say that they're moving in the same direction in this space. And words that have different meaning are moving in different sorts of directions. And so I could imagine that in this kind of meaning space or semantic space in my head, I could have words like armadillo and surgeon, and they probably won't be very close together because those words, if I say armadillo, surgeon does not come to mind. On the other hand, if I say scalpel, surgeon comes to mind. Right? So the words scalpel and surgeon could be closely related in this semantic space, armadillo and surgeon further away in the semantic space, or at least moving in different sorts of directions. And so Space, of course, we can think of in terms of 2 dimensions, say longitude and latitude, right? I can give someone a coordinate system and they can find a particular location in space. There's a limit to how much space is there in 2 dimensions, especially if we're just dealing with directions, right? So if we're just talking about how many directions you can go, you can imagine the space is going to get crowded, especially when we think of vocabularies of tens of thousands of words. We're going to run out of room in a 2-dimensional space. In the real world, when we run out of space, we can build up, right? We can have high-rise towers, so we can add a 3rd dimension. So I'm going to be at a particular corner, and I'm going to be on the 10th floor. Great, now I've got more space. If we run out of space then, we get too many people, then let's timeshare. I'll be at a particular floor, in a particular building, in a particular street, corner at 10 o'clock, right? You might be there at 11 o'clock. So now we've created even more space. We can pack in even more people into this space. So we're going to take the same principle here with Word. We're going to just increase the number of dimensions, right? Directions that we can go in order to give ourselves breathing room in terms of this space. So how much space are we going to give ourselves? Again, arbitrarily, we're going to give ourselves 3,000 dimensions. I know that seems like too many, right? We had 4 dimensions to deal with too many people in a particular space, but the math is the same, whether you've got 2 dimensions or 3,000 or 10,000 dimensions. Really doesn't matter, right? So why not go for 3,000? Plenty of space, we're not going to run out of space, so let's just do that. And the way to think about space is if I gave you coordinates, it'd just be 2 numbers, right? I could say 25 degrees west and 38 degrees north or something, and that's 2 numbers that describe a direction in space. So here it'll be the same thing. It'll be a list of numbers, and that's really all a vector is, right? It's just a list of numbers, and we can infer a direction from that list of numbers. Now we can't really think about 3,000 dimension, at least I can't think about 3,000 dimensional space. But fortunately, we don't really have to. All we need to really think about is that it's a lot of space, right? Potentially. Okay, so when we think about semantics, we're going to have our meanings of words. We're going to have similar words like scalpel and surgeon moving in similar directions in a 3,000 dimensional space. And so that means that each word has to start at least with some position in this 3,000 dimensional space. So if we have the word dog, for example, and again, this is completely arbitrary, you can see down there, this is our 3,000 dimensional space. I can't fit 3,000 numbers, so I just put some ellipses halfway in there. And there's a bunch of zeros. A 1 there appears in the 3rd position, and I think we've got a -1 in the 6th or 7th position. And in the model that I'm going to describe, which is called the random permutation model, name isn't terribly important, starts with all words occupying some position in this 3,000 dimensional space. The vectors, or these lists of numbers, are mostly zeros. It's 98% zeros, 1% ones, 1% negative ones. Those aren't details that will matter very much. So we start with these words in some random location in this 3,000 dimensional space, and eventually they're going to be organized in such a way that similar meaning words will occupy a similar direction, and meanings that are unrelated will occupy different directions. So the vector part is okay, right? You just assign vectors to words, but now those vectors have to change. In the same way that if I were to interrogate, maybe too strong language for a baby, if I interrogated a baby about their meaning of language and meaning of words, they're all the same, right? The armadillo and surgeon are just as related as surgeon and scalpel because they don't know what any of these words mean. So it's just nonsense to them. So we're going to have the model start the same way. We're going to randomly assign these positions in space. It doesn't matter where they are. And then through experience, the computer will come to shape the meaning. And so the model I'm going to talk about is something called the random permutation model. I don't know if I'm on the right spot. Yeah. And the random permutation model is one in which, again, we have these words assigned randomly, hence the name. It's not a neural network model. I'll talk about those a little bit, even though I don't use them. It's a simpler model, but it works. And so what we're going to do is we're going to have the computer iterate, so cycle through sentence by sentence. And each time it encounters a sentence, we'll consider a particular target word. It's going to do this for all the words, but let's think about one target word. And it's going to change its direction based on the other words in that sentence. So how do we do that? So here's a sentence. The dog bit the mailman. We've got a dog bit the mailman. And you'll notice that because dog is our target word, the word under consideration for now, we're going to blank out its vector. It doesn't get to influence itself. That doesn't really mean anything. So it needs to be influenced by the other relevant words in the set. Now, another quirk of this model, if you don't do this, it doesn't matter too much. We assign values of just zeros for words like a and the. And the logic there is that because they appear in so many different sentence contexts, they don't really contribute to the meanings of other words, right? The word the is just not shaping the direction of a word. If you don't do that, it doesn't matter too much. It just kind of wastes some computer time. So it's a practical sort of consideration. Okay, so let's see what happens with a dog bit the mailman. So with a dog bit the mailman, there's a vector for all of the words except dog, because that's the word we're taking into consideration here. So a and the we'll not worry about. We'll just put zeros for them. And we've got the word ball there, and it's 0, 1, 0, 0, -1, a whole bunch of other numbers that we don't know about. A few zeros, a -1 and a 0. And then the word mailman, I got 4 zeros, a -1, a whole bunch of other numbers, and then there's a 1 there at the end. Okay. Most of the numbers we're not going to worry about. The only ones we care about are the ones that have the squares around them. In other words, the words or the numbers that are the same in the same position. So they overlap. They have a shared kind of component of their direction. And what we're going to do is the meaning of dog, what dog gets out of this sentence is that overlap. So we just carry through the overlap part, which is the shared direction of bit and mailman, and we're going to add that to the meaning or the vector for the word dog. And we just do that for every single sentence. So if you went through, say, 300 books, it has about 10 million sentences, for example, you do this about 10 million times for the word dog, and you do it 10 million times for all of the words that appear in all those sentences, which, by the way, doesn't take very long with this model. It's a very simple model, and doing this carrying through of direction is very efficient. So on a laptop, it might take you like 5 minutes to do all of that. Okay, so the addition of all of these vectors, right? In the same way that we can add directions, right? If I go north, I can add west, and I keep shaping my direction. We're just going to add all these together. So all of the meaning or the direction that we get from each individual sentence will just keep being added up until we eventually end up in this direction that gives us the total meaning of all instances of the word dog. Okay, so I want to now apply this kind of method to various groups that may use language differently, or groups of text, I should say, that may use language differently. And so I want to just give examples from two different kinds of groupings. One has to do with different kinds of news sources. So Canadian American news sites specifically, and there they are listed: CBC, Globe and Mail, National Post, Toronto Star, Breitbart, CNN, and Fox. Fox News, I think people are familiar with, right? It's a right-wing American news source. Breitbart, I don't know if people are familiar with. It's a further right American news source. So if you think about Fox on steroids, that's Breitbart, basically. And then academic groups, obviously a little bit self-indulgent, but so groups like accounting, biology, chemistry, economics, fine arts, psychology, and I got that text from the Open Textbook Library. If you ever need a free textbook, there you go. Okay, and in terms of thinking about this semantic space, I mentioned that the words are going to be these vectors of 3,000 dimensions. I don't think it's going to be helpful to anyone to see 3,000 numbers for a word. Certainly wouldn't be helpful for me. So there are ways of visualizing the space that don't involve 3,000 dimensions. The one thing we can do is use a statistical technique to reduce or to capture as much information from those 3,000 dimensions down to 2, which will conveniently fit on a screen. So that'll be nice. So we can get a 2-dimensional plot that captures the direction or meanings of words. The other kind of statistical approach that will be factored in there is something called k-means clustering. So basically what that means is that groups that are sufficiently close statistically will be colored in the same color. So we can kind of get a sense of which things are closer than others, apart from just the distance itself. And you'll notice that some of the circles are going to be bigger than others, and that's a reflection of how often or how frequent the word was in each of those news sources. The other thing we can do is whenever we have directions, we can calculate how similar they are by taking the cosine of the angle. So we're going back to trigonometry from middle school or whenever you learned it. So the cosine of 0 is 1. And that basically means that if I've got two directions right on top of each other, then I get a cosine angle of 1. If they're at 90 degrees, so they're completely unrelated, then I get a cosine angle of 0. Okay, and if they were 180, which doesn't really happen very much in the model, you get like a -1, but generally we're dealing with numbers between 0 and 1. So the closer to 1, the more related they are. Very few numbers are 1, so even something like 0.2 or 0.4 is considered pretty good. That's related. Okay, so we can rank order all of the words in comparison to a target word. So I could say, okay, I've got the word dog, I've got 40,000 other words in my vocabulary. Let's put them in a list, calculate this cosine angle to every other word, and say which are the top 10 or the top 30 or whatever you'd like to look at. What are the most related words to dog? Okay, so that's another thing we can do. I just call that the nearest neighbors, the neighborhood of the semantic space. And then we could also pick two words of interest and say, well, what's your cosine angle? Right? So I could pick just two arbitrary words like armadillo and surgeon and say, well, how similar are those two words? I get one number for that. Or scalpel and surgeon. Presumably the latter will have a number closer to 1. Okay. So if we're looking at these plots, I can't tell what people are looking at, but that's okay. Okay, cool. So here's one, and I apologize for the overlap there in the top kind of left part of the graph there. The nice thing about vectors is they can be added. We can just perform normal mathematical operations. If I want immigration-related words, I could take a bunch of words and just literally add up their directions, and I get some average immigration-related word. It's not a real word, but it represents that direction. So here I just put in immigrant, plus immigrants, immigration, migrant, migrant, all immigration kinds of related words. And took a look at all of these different news sources and how they represent them. The horizontal and vertical axes are kind of, they're not meaningless, but they're arbitrary, in the sense that the statistical technique has decided this is the most efficient way to represent the two dimensions. I can't label what those dimensions are because I don't know what they mean. It's just a statistical kind of grouping. But we can kind of infer meaning once we start looking at things after the fact. So one thing you'll notice is that the clusters here, CBC and Toronto Star, are statistically considered to be similar. They're both, I think, blue. The Globe and Mail is off by itself, and so is the National Post. Fox News and Breitbart, and I mentioned that Breitbart's a right-wing source, are grouped together, very unsurprisingly. And CNN is all by itself. You'd also see that Fox News and Breitbart in particular, spends a lot of words talking about immigration. Yeah. Oh, sorry. Oh, okay, there we go. Does that make sense? Thanks. Right, so hopefully that makes more sense now, right? So we've got these circles, and there they are. Okay, so they spend a lot of effort, I guess, or words on these immigration-related words. And these are also, by the way, scaled to the total number of words that are used in each news source. So if one just puts out more stuff, that doesn't affect this. It controls for all of that sort of stuff. Okay, so we have this kind of separation. Now, this doesn't tell us in what way these things are similar or different. It just tells us that they are, which, as a psychologist, is not that satisfying, although pretty to look at. So let's take a look at the actual nearest neighbors. Let's look at the neighborhood for words. And so I picked on Fox and CNN, and I'm not going to make people read too much, so I've just bolded the words that are different. And so we've got aliens and alien under Fox when they're talking about immigration-related issues, and the more neutral words undocumented and asylum when CNN is considering immigration-related terms. So right away you can see that the language usage is different between these two groups. Okay, and I kind of have to admit I've kind of purposely selected examples that I think are kind of obvious just so that it's intuitive, that the computer is doing the same things that we would come to without any kind of pre-existing bias or anything like that. Okay. Let's take a look at something else. Oops. Yeah, let's take a look at this. So I also want to emphasize that these groupings or clustering of groups is going to potentially be different for every single word. So it's not always going to be the case that the Toronto Star and the CBC are going to be similar in how they talk about every single thing. Right? They might be different in some areas and similar in others. So here's some different terms, some economy or economics related terms, debt, deficit, economics and economy. Just add all those things up together, get some kind of fuzzy economics direction there. And now CBC is all by itself. The Globe and Mail and Toronto Star are now grouped together in terms of how they talk about this word, and the National Post is still by itself. Also, the American news sites are now clustered together. Okay, so they were different in terms of how they talked about immigration, not as different when they talk about the economy. Okay, so I want to pick on the National Post and the Globe and Mail on the next slide here, and how are these different or similar? So I've underlined now words that are the same in both groups that I just kind of want to emphasize, and I'm keeping the bolding for words that are different. So the National Post talks about budget, province, liberals. This is data that was collected, I should mention that these are words that were collected from April 2018 to summer 2019, it was in that year period. So it doesn't reflect current word usage, which might matter. Whereas the Globe and Mail is talking about surplus growth and gains. Seems like a more positive kind of take on the economy in the Globe and Mail. And the things they have in common are things like, well, Canada and spending. I mean, they're both Canadian news sites, so that's hardly surprising, but that would drive a difference with the American news site. So the differences will not always be ideological necessarily, they could be geographical. Right? Okay. So I also like to look at academic disciplines. Again, as an academic, maybe unsurprising. So what about the word research? So first of all, we can see that I think this is hopefully intuitive. Chemistry and biology are together, right? These natural science areas. The fine arts by itself. Economics and accounting are together. And psychology and sociology are together, right on top of each other. And they also have giant circles. And so this either means that they're doing a lot of research or really insecure about the research they're doing. Hard to say from that plot which it is. They talk a lot about research. Okay. Let's take a look at what's driving some of this potentially. We look at psychology and sociology. So they use the word conducted or conducting research, just a language convention there. Ethical comes up. I think that makes a lot of sense. Both disciplines deal with working with people potentially, and so when you're working with people, there's ethical considerations that are always at the forefront of doing research. In biology, there's still ethical considerations, but I don't think they're as front and center because we're not dealing with people usually, but you can see scientific, science, and discovery. Right? I find that an interesting one because we talk in psychology about conducting research. We don't really talk about making discoveries, but in the natural sciences they do. And I can't think of a great reason for that, to be honest. I don't think that there's discoveries everywhere, right? In the arts, everywhere. But for some reason, just the way we use language, we don't tend to say that. Okay. And again, another sort of, for me, a very common association, and the model bears that out as a psychologist, is the connection between the word research and subject, right? So we talk about research subjects all the time because we're dealing with people. Sometimes we're dealing with non-human animals like rats. We still talk about them in terms of being subjects. So that association is quite strong. So that 0.477 again is closer to 1 than it is to, or not closer to 1 than 0. I don't want to embarrass myself mathematically, but it's closer to 1 than any of the other numbers on that list. Right? Sociology is next, and I think that makes sense. Whereas biology and chemistry are the lowest. And with chemistry in particular, you're dealing with things like compounds and molecules. You wouldn't be dealing with subjects. So that hopefully works. But again, just like the kind of political news sources, I want to emphasize that these groupings are word specific. So psychology and sociology are not always related. If we look at the word history, then now psychology and biology are grouped together. They're the same color. Sociology now, interestingly, the fine arts now has a partner in sociology in terms of its history. Now, I don't know enough about sociology or the fine arts to know what's driving that. But I think that's kind of interesting. Chemistry is by itself, and apparently chemists don't like to look back very much because they don't talk very much about history. And accounting and economics are still together. I'm only realizing as I say this how biased I am towards psychology because it shows up in every slide. I'm sorry. I should have highlighted fine arts more given my audience. But, we've got psychology and biology here. So what's driving this commonality in history? Well, there's a strong evolutionary component to both. I think with biology that makes a lot of sense. But if you've taken some psychology, especially history of psychology, you'd know that that's true in psychology as well. It's not always a very flattering history in terms of what's happened with kind of this evolutionary take, but it's there. It's part of our history. Okay. So that's kind of what we get out of the models, and I've picked examples that I think are hopefully relatable for the most part. The academic ones maybe not as much. Hopefully the news source ones are kind of obvious. But that's not really good enough, right? I mean, it's one thing to say, well, our model is iterating through these sentences, and it's coming up with these associations. They look fairly sensible. But what about a more rigorous kind of demonstration of that? So if this is true, then we should be able to make some kind of prediction about people based on what our computer model does, right? One thing that we know about people is that we are much faster at making a decision about whether some letters that appear before us are a word, right? So we're not even interpreting or figuring out the meaning. We're just saying, is that a word or not? If that word is already in our mind, right? So if I've got a word in mind and you showed it to me, I'd be like, yeah, that's a word. If I didn't have that word in mind and you showed it to me, I mean, I'd still know it was a word, but it would take me a little bit longer to figure out. Right? It'd just take me maybe tens of milliseconds. I'd be tens of milliseconds slower. So it's not a huge difference. We're not talking 30-second pause, but you'd be a little bit slower, and that difference is measurable. So that's known as lexical decision, right? That I'm making a decision about just whether or not some letters are a word. How do we put a word in mind? Well, we do it based on association. If I give you a word and you have an association of that word with a bunch of other words in its neighborhood, its semantic space, then all of those words should be active. So if I said the word surgeon, scalpel should be activated in your mind to some extent, consciously or unconsciously. And if I now show you the word scalpel, you should be faster to say, yep, that's a word, than if I had said the word armadillo, if that makes sense. Okay. So that's known as semantic priming. Again, semantics has to do with the meanings of words. So we're activating the meanings of related words. Priming is influencing your future behavior based on something I'm doing now. So if I'm priming you for something, I'm getting you ready for something. I'm getting you ready to make a judgment about the word scalpel in that particular example. The classic example is something like butter. I say the word butter, people think of words like bread and knife. These are all things that we use with butter. Now we have a way of doing that with the computer generated word associations. We have that kind of semantic neighborhood, right, where we had a list of words that were related. And more specifically than that, we could potentially generate different lists of words for example, different academic disciplines or people that read different news sources, because we saw that those associations are different. And now if we talk to someone that reads, for example, the psychology literature or reads the CBC or reads whatever news source, then we should be able to infer something about some of their associations, assuming that their associations are shaped in part by their reading experience. Okay, so we can now make a prediction of what word will bring to mind another word based on what the computer has already told us. So how do we do this practically in a laboratory setting? Well, I can tell you that what we did is that we collected information about political views, the readership of news sources, that's the critical one here, and other sorts of demographic information. So things like gender, age, just to make sure that we didn't have differences on that basis between the groups from a group of people. We just found a whole bunch of people, we collected this information. This study was actually done online in order to get the American participants. And then you present a word very briefly, and by briefly I mean half a second or so, which is plenty of time to read the word and understand its meaning, quickly followed by another word. So you'd see butter flash for about half a second. You would consciously process it, so there's nothing subliminal going on here, and then see another word like knife. And then you'd be asked the question, well, is knife a word or not? Right? And of course you know that knife is a word, but the main measure here is, well, how fast do you say that it's a word? And if you can indicate that faster, then I think that you had an association in your mind between butter, that's actually me, not, but that was a special effect for a second, but it wasn't. And so that's the idea. So the way that subjects indicate that something is a word or not is they just press a key on a keyboard. So there's one key, I think it's the F key for not a word, and then H or something, easy home row keys for it is a word, right? Both are the same finger, so there should be no difference. Okay, so like I said, accuracy is high. So we're looking at speed. That's our major sort of measure. In order to test whether or not people have the same kinds of associations as the computer suggests that they should, based on readership of those things, we asked our computer to come up with word pairs that were very similar. And there's a few different conditions, and I know this is like too much, and so I'll just kind of explain it really quickly. We don't need to read all the words. The word pairs there. So the word pairs are things that in the congruent condition, congruent just means it fits, right? So these are words that fit with one another. They're highly related. And these are words that are highly related for everyone regardless of which news source they read. So in regards of news source, words like trailer and tractor were highly related. Right? Those are not particular to any news source. Incongruent means they're not related, right? So we need a kind of a baseline to see if there's a speed improvement or not. So these are the words where you don't get any advantage. So for example, a word like cloud and venues. I don't think in most people's minds, if I say cloud, venues comes to mind. Now we've got the interesting groups. We've got the Fox. I compared Fox News and CNN for a couple of reasons. I picked those two because generally when you publish in a journal, they're more interested in Americans than Canadians. That's just an unfortunate reality. But also these are two different news sources and they both have wide readership. So it's easier to get people that can find that read these things. So for example, these are selected on the basis of they're highly similar. So for the Fox ones, they're highly similar in Fox News, but they're not similar in CNN. So they were intentionally selected to be similar for one group and different for the other group. So border and crisis go together in Fox News. I'm sure everyone looks very shocked by that, but there it is. And with CNN, for example, culture and art go together, but they don't as much for Fox News. So for example, just two random examples. Okay, and that's it. Those are the words. Now, in order to do this task, you can't have everything being a legitimate word. Otherwise, the measure is useless. You could just sit here and hit the key as fast as you can. You'll always get it right. So we have to have a bunch of strings of letters that are not words. And there they are. And I can't really talk about them because they're not words. So by definition, they're not language. But there they are if you're curious about what they look like. Okay, so what happens? Well, there's a prediction here, right? And the prediction should be, well, if you're a Fox News reader, I've identified you as such as a participant, then when I give you a prime, a semantic prime that's from the Fox News corpus, or the set of text, then you should have a speed advantage for that particular association. Whereas if I give you a word that is from the CNN one, you won't have that speed advantage. And so the words CNN and Fox appear too many times on this graph, but I can just tell you that on the bottom there, we're looking at the computer-generated pairs. So on the left, where it says CNN, that means that those are word pairs that come from the CNN set of text. And the higher the number, the faster you are. It's the speed advantage over the neutral or incongruent terms. So basically what we can see there is that CNN readers, because they're higher than the Fox readers, right? The blue is higher than the red, means they have a speed advantage if the word pairs come from CNN. And that's exactly the prediction, right? If I give you culture and you're a CNN reader, you think art, but if you're a Fox News reader, presumably you don't. And so the CNN reader can respond more quickly than the Fox News reader can. That's the inference there. Now you'll notice that if that's the prediction, these things should be an X. They should cross over. They don't. So what's going on the other side? Well, they're the same. So if the news pair is from Fox, CNN readers and Fox News readers are equally quick. Right? That doesn't seem right. So what's going on there? Well, part of the problem is that we ask people what news sources they read the most. So we don't know that these are the only news sources they read. What's the other problem? A detail that sounded minor maybe when I said it, but it turns out isn't. This data was collected over 2018 to 2019 when Donald Trump was president. Donald Trump sent out over 1 million tweets during his presidency. We counted. It's part of another analysis, so I'm not making that number up. And they were disseminated widely. So the problem is, even if you're a CNN reader, you're reading Donald Trump's tweets, which look a lot like the Fox News site in terms of the language usage. And so you would have both associations, which means you have a speed advantage from both sets of word pairs. Works. Okay. Okay, the second thing I'd like to talk about is attitudes and tone. So the emotional kind of content of language. Sentiment is this, am I receiving information as being toxic or not toxic, civil or not civil, that kind of thing. There's lots of techniques to investigate this. The simplest is just to have a list of words that people have decided are toxic, and that's actually not that hard to do, right? We know what words are bad, and say, well, how often do those words appear when people make particular types of utterances or statements? So you can count frequencies of those words. The other thing you could do is you could get fancy and train an artificial neural network to make those decisions based on feedback from human raters. In other words, I take a sentence. As a human rater, I'd say, yeah, that was pretty toxic. I'd have a neural network that would give me some random answer at first, but then I would correct the network by giving it the answer of a human rater. It would go back and adjust its algorithm or its weight, its connection between nodes, and eventually, if you do that enough times, it'll start giving you answers like human raters. So if you're not used to seeing them, this is kind of what a picture, or sorry, I don't have a picture yet. The way that artificial neural networks work very briefly is they're based on how the brain works, right? We've got a lot of neurons, they're interconnected in complex sorts of ways, and when we have one stimulus followed by another, we tend to strengthen associations between connections, or if there's a reward or something like that. So we're kind of back to Pavlov's dog, right? If I ring a bell and I feed my dog learns to salivate eventually when it hears a bell, because it now connects a bell with food. So we can do the same thing with language or sentiment or any other manner of things. In this case, as I mentioned, the input is going to be words, and we represent words with lists of numbers. So that hasn't changed. We're going to have a vector of numbers. But we could also have a vector of numbers that represents a picture. It could literally be luminance values of the pixels on a screen. That could be a vector too. So anything can be a vector. And through this kind of iterative learning process with feedback, the network will learn to produce the right answer. Now, the problem with these sorts of, it's not a problem, but what are the kinds of features of these sorts of models, though, is that they're hard to interpret. So here's just like a picture of an arbitrary neural network, right? Take a look at how many arrows there are. So what's really going on is I have some number in one of the nodes, in one of the circles, say in the input. That's something I can see, a stimulus. I multiply that by some weight, the connection going into the next node, and all of those lines can have different weights, by the way. It's not the same number. And then I add up all of those numbers multiplied by some weight in the next node, and then I keep doing that going forward. So by the time you get to the end, you've got a whole bunch of numbers that are very difficult to decipher. This, by the way, is a simple neural network. We can add, right? We can make another layer to our neural network. If you're interested in ChatGPT, it's a neural network that has about 12,000, the ChatGPT version 3, it probably got more complicated now. It's got 12,000 input nodes for each word. It's got 50,000 hidden unit nodes in one layer, and it's got 96 of those. And then it's got an output. In other words, there are 1.75 billion nodes. When you talk, if you read about these models and hear about their number of parameters, that's what they're talking about. The number of those little circles. The number of arrows is much greater than that, right? There's tons of connections. So they're very hard to interpret in terms of exactly how they're working, but they give you the right answer. So it's great from an engineering point of view, not very satisfying from a psychological point of view, because the job is to understand how people work. Okay, so again, that was a bit of a diversion, but one question people often ask and have an intuition about is that people are becoming worse. People are becoming less civil in terms of their politics. We have one example that's easy to come up with. What about other people? And are they becoming less civil everywhere? So again, we looked at this in the American context. My colleague and I did an analysis of American tweets from 2009 to 2019 using computer-generated sentiment scores. So they were generated using one of those connectionist kinds of models or neural network models. But we also looked at other types of political speech, congressional speeches, presidential debates, those kinds of things. Okay, and just to give you a sense of what's civil and what's not, I've got these here because I can't read that. So here's just an example, and civil and not civil has nothing to do with agreement or disagreement. You can disagree in a civil way, and the computer will not grade that as not civil. It'll say, like, that's fine, that's civil. So for example, here we've got a speech, the Pelosi health mandate bill is going to destroy our economy. This is a dead, rotten, stinking fish that the speaker is trying to force down the throats of the American people. Any guesses? Civil? Not, anyways, not civil. Right, on the other hand, you could say something like, The Stupak and Nelson amendments would disrupt the 30-year status quo on abortion coverage to the disadvantage of women's reproductive health. Still a criticism, but it's civil. Right? There isn't an insult thrown in. Nothing is rotten or stinking. Those things help. Right? So that's the basis. We're looking at emotional tone. We're not looking at the content or disagreement. Let's take a look at what's going on with Twitter. And so what we can see with Twitter is that, unsurprisingly, it's highlighted there, Trump was toxic. I mean, it's not really hard to figure out. So on the vertical axis there, the higher that number, the more toxic the speech. Across the bottom there, we're going over time. So if we're looking at the left panel for now, we can see that Trump was more toxic than previous presidents in terms of his speech. But what we can also see is that Congress, it's harder to see, the light kind of purple there, is also going up a little bit. Not as much as Trump did. But my favorite thing about this graph is that as toxic as people like to think Trump is, he is not as toxic as the average person on Twitter. The worst part about Twitter is everybody else. Twitter, I mean, if you've ever heard Twitter is a cesspool and you need to prove it, just this is the picture to prove it, right? You say, well, do you think Trump is bad? Yeah, well, everyone else is worse, right? On average, not everyone. Okay, so on the right side, that's breaking down the light purple. What's driving that increase in Congress? And it turns out it's actually, I'll just focus on the solid blue line because the other ones are relatively flat, it's liberal Democrat. It's not the Republicans, it's the most progressive Democrats that are becoming more toxic, which is kind of interesting. You could argue that could be that they're fighting with Trump. That's a potential reason, but there could be others as well. So that's Twitter specifically. Well, what's going on otherwise? Well, not much, right? Congressional speech actually hasn't been getting worse. People on the floor of Congress, they're not becoming more toxic. If anything, there's a trend downward. Presidential debates is noisy because there's not as much text there. But what you can see is that there isn't a general trend up. Again, there's one debate in particular, or one set of debates with Clinton and Trump that's particularly toxic. Okay, so what's special about tweets? That's what I want to get at here. I won't dwell on this slide because I think I'm running out of time soon. But well, the thing about Twitter is that over time, if we just look at uncivil tweets, just the toxic ones, then people tend to like them. They get rewarded for toxic messages on Twitter. And they also get shared. So there's two measures on Twitter. I get to use the word Twitter because this is from years ago when it was Twitter, so I'm not wrong here. But you get retweets, which is how many times people share your message, and you get how many times people like it, right? They approve of it. But here's the problem with that. So again, incivility, as it's going up, you get more retweets and more likes. So that sounds like more approval overall. But one is going up faster than the other. And this minor detail matters a great deal. The retweets are going up faster than the likes. And it's the wrong way to think about reward, right? So if I said, I gave a talk to 20 people and 20 people like the talk, that's pretty great. If I give a talk to 1,000 people and 20 people like the talk, not so great. But on Twitter, that's 20 likes either way. So the thing is, retweets give you a sense of your audience size, and you should really be dividing your likes by your retweets to actually figure out if people approve of the message. If you just look at the raw count, it's misleading. And here's the example of that. We did an experiment here, so we just asked people instead of just relying on the classifier. So there's a civil example here. I don't think I'll read these just in the interest of time. But what you can see is that the civil example gets 23 retweets, 184 likes, kind of moderate levels, well, kind of low levels. Bluish levels are cold. Sorry about that. I'm adding my own sound effects. But and the red levels are high in terms of percentile. So the retweets and likes are relatively low for this civil tweet, but the likes per retweet is 8. So in terms of controlling for your audience size, that's actually quite high. And when we ask people if they approve of that tweet, human judges, they do. It's positive 2.9, and we control for people's political views and all that. So this is not partisan stuff. If we look at the toxic tweet, 2,200 likes, or sorry, 2,200 retweets and 5,000 likes. That person's getting a lot more signals about approval, but that's only 2.3 likes per retweet, and that tweet is not viewed with social approval when you ask people directly about that tweet. In other words, Twitter is setting people up to be misled about what people approve of. They think that they're approving of these tweets, but they don't, because they're misled by not dividing or not considering the audience size. And so that's my summary here. If you just divide those two numbers, you get a better sense of approval. And my overall conclusion here is that computational methods give us this way of extracting meaning and sentiment from large amounts of text. And really the benefit here is the lack of bias and the large amount part, right? We have so much text out there, we can't possibly read it all. So having computers help us is very useful. There's controversy sometimes around things like large language models hallucinating, being confidently wrong, having particular types of biases. These models aren't really doing anything magical. They're holding up a mirror to ourselves, right? Any biases we see, confident hallucinations, that's because that's how we write. That's what we're offering up on the internet, and the models are mimicking what we do. They're recombining in interesting ways, but ultimately those problems are problems in terms of how we communicate. Okay. And I think that's it for me. Thanks. Okay, are there any questions? Or I'll defer to figure out how the questions work. Yep.
Yeah, thank you so much.
Oh, thanks.
I have so many, but the first thing that comes to mind, I can relate.
Okay.
It's really interesting to me how like how understanding there is of that felt like the person is the main driver is the persons and they were company or take your message
Mm-hmm.
and then found a way to but they couldn't say anything like it.
Yeah.
And it's also a different that pay to see what looks like God.
Okay.
And then political pay so that applicants see their so it goes both ways. Pay to make people
Okay.
certain
Mm-hmm.
even buy along interest.
Right.
They don't want
Right. Yeah, for sure. Yeah, I don't know as much about the legal framework. I know the New York Times is suing ChatGPT and these other sources. I think legally, and this is just from what I've read, not from what I've researched, but what I find interesting is that the argument isn't so much that it's not only that, well, you're scraping things over permission, because I think there's been other cases that have been lost like that, but rather you're misrepresenting what we're saying. So now the problem is if one of these models generates a quote attributed to the New York Times and it's wrong, then that's, I don't know if that's slander or libel, I always get those mixed up, but it's something not good. And conversely, they can't really say, well, we're not going to cite you because that's problematic legally as well. So I know that there are efforts to kind of combat that. I don't think it's necessarily on the kind of the ethical grounds. I remember reading something else about robots. You know, like you can put a little file basically saying that you may or may not kind of scrape me as a searcher or web crawler for information, and how if that could potentially be repurposed to prevent these models from being trained on those data sets as well. Yeah, so, sorry, I don't know if that answers your question, but yeah. Any other questions? Or maybe question?
Well, it's different. Yeah, I'll ask. Well, I specifically think my earlier looking at clear.
Mhm.
That psychology and sociology is big research, the term research is much bigger than everything else.
Yeah.
Findings and it made me think about the applications that I get in some ways of epistemology, which is kind of
Mhm.
philosophy where you have the fields that don't really use the term research as much, they're referring to their findings, and you kind of did this like where you where it's said this, like
Mhm.
they're referring to their findings as like what they're seeing in the world.
Right.
These are what the world is, what it's showing,
Mhm.
its relationship to their research as viewing aspects of reality, whereas psychology, sociology is reflectiveness that say what the research shows. It's
Right.
brain between what they say and what is in the world. It's a lot of self-awareness.
Yeah, I agree with that. I think, yeah, that word research in these different academic disciplines, like you said, in the physical sciences, the natural sciences, it's there, right? Like it's objective. We can see it. It's a discovery, and I think that's why the word discovery is there, because we're revealing things out in the world or understanding them. In psychology, it could be a caution that there's being reflected there. We're researching things. We don't see them. We're kind of inferring things that are hidden in mind, for example, or in society in terms of hidden structure. I also think that part of it could be that in psychology, people talk a lot about the disunity of the discipline, that it's not, maybe you shouldn't even have a term, right? That people they study very different things in very different ways. And so as a result, you can't really say experiment. Some people do experiments, some people don't. And so because we can't use those precise words to talk about our methods, we use the more general word research. Right? And so that could be capturing it as well. So whether you're doing an experiment or an observational study or something else, a literary kind of analysis, we can call all of that research and still be kind of a unified sort of discipline. Whereas in chemistry, you could just say I'm doing an experiment, right? Or I've discovered something.
That's using the psychology methodological lines.
Yeah, exactly. I don't know enough about sociology to know whether that statement would hold for sociology, but yeah. Sure.
What is the different way to look at the quality of the definition that we define? So if we use the example of freedom,
Mm-hmm.
something's prime, the idea of freedom is prime for you. I wonder, is there any question about how broad that definition is for the robust?
Yeah. Yeah, no, I like that. Yeah, and so like at an individual item level, you could certainly look at like, well, did this item improve reaction time versus that other item, right? I'm only showing you averages across all of them, but there are certainly differences between those items, and I have that information, I guess. But yeah, some of them work a lot better than others, and so I think if that's getting at what you're saying, the quality of the prime, is this does this bring to mind something more cleanly than something else? Part of it has to do with some of the models talk about semantic distinctiveness. So it's not just the two words are related, but that they're uniquely related. Like scalpel and surgeon are not just related, they're kind of uniquely related. Because it's not just that I use the word scalpel in sentences with surgeon, I don't really use the word scalpel in sentences without surgeons very often, right? So if I have a word that follows another word closely, but also tracks other words, then it breaks that kind of connection in some way. You know, so does that get at kind of this idea? So I think the higher quality ones would be ones that are uniquely associated rather than just kind of loosely associated.
Word use outside of the prime. So
Mm.
well, on freedoms, I think it is
Sure.
use to bring it up as an example. So one person
Yeah.
see something.
Mm-hmm.
Does your definition say robust? I mean, is it very useful in the world, and is it easily defined by the user, the individual, or does
Yeah.
it actually close down for you? So if you're getting the word freedom every day,
Mm-hmm.
does that mean that your definition is like a healthy? I would sound like a
Yeah.
judgment, but like a healthy. Sometimes you can attribute your use, I suppose.
Yeah.
So you say it so many times, meaning it's good.
Exactly. Yeah. And so that's kind of the other sort of aspect. It's like, well, if I'm using this word, it's shaping my meaning of the word, but maybe is it doing it in an explicit or, so I could still literally know the definition of the word freedom, right? I could rhyme that off for you. But in terms of like my gut feeling when I hear that word or my reaction, right? Or, what just comes to mind when I see a particular situation, that would be very different. I would be interested in that. I don't know how to study it, but like that disconnect between dictionary definition and someone's language experience with the word. And if those things grow further apart, how do people reconcile those things? Right? Because you're right, we do know the dictionary definitions of certain words at least. Yeah. Oh, sorry. Hmm. Mm-hmm. Oh, okay. Mm-hmm. I haven't looked at those things specifically. Part of the challenge with these models is you need a lot of text. So for example, let's say, just to pick a random company, like Apple's trying to convince me that they're the company for privacy. I'm just making that up. I don't know enough about their marketing. They can put out ads. They can try to create that association in my mind, which is kind of shaping my definition of an Apple product, for instance. But the question would be, how much can I read from? Will I get enough kind of language exposure through their efforts in order to shape kind of my experience? So if I had a company, and if I understand your question correctly, like trying to shape language, they would need to expose you to a lot of language, right? So I think like an individual by the time they're about 7 years old hears about like 100 million words or so. Like we hear a lot of words. So my computer is reading, but of course we experience words through dialogue, those sorts of things. So they could, and I think it would be, again, getting back to the previous point, more effective if it's a unique association, right? If I'm not hearing about their product through other means, but they're trying to attach it to something else, then it could work better. I feel like I'm not quite getting it, but. Oh, okay, yeah. Yeah, yeah, oh yeah. And our words evolve over time with usage, right? Like the word computer, I think, is an interesting one because university now refers to a machine, but that's not what computer meant when, back in the day, computers used to be people that did computations, right? That's what a computer was, a person that did stuff. Now, when I say the word computer, no one thinks of a person doing a computation. We think of a machine doing it. So somewhere along the line, we just kind of shifted that over. Right? I was thinking earlier about cybernetics, which sounds very high tech and fancy, but it's like an old area. It's an old discipline back from the 50s. That's mathematical discipline that study dynamical systems. But we don't think of cybernetics that way anymore. So again, it's just language usage just kind of evolves, I think, over time. But I think, yeah, intentionally or otherwise, definitely whatever's going on is going to shape language. I don't know enough young people, I guess, but I suspect they have very different language and slang that I won't understand. And I imagine in part due to things that are happening in the technology world, right? Like on YouTube or TikTok or wherever young people are, I'm out of touch, but wherever they're spending their time. Yep. Yeah. Hmm. Right. Hmm. Okay. Sorry, I missed that just because. Hmm. Yeah. Yeah, it's a great question. Yeah, like these words that signify sound. There is, and this model's even, I mean, we could step back, it's even worse than that, right? Because there's not even a consideration of phonetics, period, right? It's just a random. So, I mean, words that sound similar, people also associate, right? And that's not, you're right to point that that's not captured in this model. There are models that people are working on that do capture that information, and they need to be integrated. So, the model that I've shown you, I kind of wanted something reasonably straightforward, but there are models that take into consideration phonetics, and so in those cases, the vectors aren't random. They hand kind of craft them to work in the phonetics, that commonality. And the other thing, and I hopefully I'm interpreting it correctly, is that if I see a word repeatedly, am I thinking about it differently than if I just see it once? And that gets back to, there's another model that deals with semantic diversity. And so what that model does is it weights in an interesting way how much information will add when you see a sentence based on whether those words are new with that target word in the sentence or whether they're old. So if I keep seeing the same sentence over and over again, I stop paying attention. It doesn't shape my language experience very much. Whereas if I see it in a new context, then I'm paying attention and it drives my direction more. If that's kind of, so there are models that process the words differently depending on how often they see them. But you're right, mine doesn't. And that's a problem. The other thing my model doesn't do is it doesn't take into account the order in which you see the word. So it reads sentence by sentence, but if you jumble up all the sentences, you get the same result in the end. And that's probably not right, right? Like if I get exposed to one definition of freedom and then I get information later, that's different if I got it in the reverse order. So that's kind of another sort of consideration. So I'm not trying to sell you on this model captures everything. I'm not going for the big sale here, just it captures some aspect of the information. Does that work? Cool. Yeah. Mm. Oh yeah, no, it's fine. I wouldn't. It's a natural inference. I mean, it's easy to look at that graph and be like echo chamber, right? I mean, that's the first thing that comes to mind. Like these ones are an echo chamber and these guys are not because they have all the associations. So they're, I think the danger there is you'd want, again, because it was a snapshot in time when we had Trump as, or we didn't, the Americans had Trump as president, you'd want to at least look at that again when there's a Democratic president, right, whose tweets are being shared broadly. Part of the problem is no one tweets as much as Trump, so you're not going to ever get that direct comparison. We looked at, that paper has a whole bunch of other people. We looked at Obama's tweets, we looked at Trump's tweets, and Obama, like over 8 years, does not tweet as much, anywhere near as much as Trump over a much shorter time period. So it is a natural kind of experiment. It's hard to do. I think it's a natural inference. I wouldn't make it just because in psychology we're kind of trained not to infer too much. But that's more of a caution thing than anything else. Any other questions? These are all great questions, by the way.
Oh,
Yeah.
actually, I was curious. In thing,
Mhm.
about accessibility of language as a measure and how rhetoric kind of relates to, or just kind of like how there's a way that language is kind of treated, and when you start to get into like this comparison of the right and the left with
Mhm.
CNN and Fox as the kind of proxy for that distinction, there is sort of a, it's, in some ways you can think of them as this kind of just different versions of talking about politics, but then there's also maybe a fundamental difference in the relationship to language that puts people interested in Fox and people are
Yeah.
feedback loop, but where language, and it's kind of a similar to the epistemology question where language is the thing
Mhm.
versus language as a way to kind of yeah, there's just something about the potential for that priming and that relationship to language as like a word being the thing versus a word being a a way to describe a thing.
Yeah.
That people are reading CNN, and I don't want to make this big inference or anything.
No, no, it's okay. You're allowed to. I just can't.
Well, that's yeah, I was curious how, like, yeah, this idea of better, like, be understood. I mean, it seems like a way to kind of track
Yeah.
the correlation.
Yeah, and there's things that are hard to capture, right? Like we can talk about like grade level, like reading level, right? Do people moderate their language because they're going for a target audience that they think is more or less educated? Who do they think their voting bloc is, right? That's a different. I remember one thing that I found interesting is when George W. Bush was president, right? People thought, well, he talks in this very simplistic kind of way, but if you ever, he was governor of Texas before he was president. And he talked differently when he was the governor of Texas. He didn't have as strong an accent. He didn't sound as hokey. He used bigger words. That was a choice that was made to talk in a particular way to have a certain kind of appeal, right? Like George W. Bush went to Yale, and like this isn't a guy that doesn't know how to string together a sentence, but you could easily kind of think that based on his manner of kind of speaking. And you know, if you don't agree with him, it's easy to say, oh, he's done, whatever the inference is. But maybe it worked, right? And I don't know enough about kind of political strategy to know how that works and how that plays. But I think that was a decision. Yeah. I don't know if that's getting it, or if I just talked about my own thing. Okay. Yeah. Mm-hmm. Right. Oh, that's interesting. Yeah. No, I think they should have. I mean, just speaking of judgment, I mean, that's bad. Like, I mean, if I did that, like, that would not, like, I get in trouble with my ethical board. So I view that as completely unethical. Yeah, no, absolutely. Sure. Yeah, absolutely. Yeah, absolutely. So I think, including this model, by the way, I don't really think of this, despite the title, as a language model. It's a memory model. And to me, words are just memories, right? Definitions of words happen to do with your memory of the usage of those words in some kind of fuzzy aggregate sort of way. And priming is based entirely on memory and association. Association is always memory. And so we don't need to talk just about words. We could talk about pictures. We could talk about other sources of information. And so there are things that will activate, if you're in a particular mood state, that will tend to activate through priming in an emotional sort of way, other negative sorts of experiences, right? This is kind of why, like, if someone is depressed or in a negative mood for whatever reason, they have better recall for all the other bad things that have happened to them. They have poor recall for good things that have happened to them. So that's probably not when you want to make a lifelong decision, right? Conversely, when you have like really good news, probably shouldn't make a lifelong decision then either, to be honest, right? Because you have kind of better recall for other things that fit in with that kind of emotional state. But I would argue that that's kind of all memory. That priming is just all association and all memory, right? And take it to a really dramatic example, even things as straightforward, or not straightforward, but as dramatic as kind of overdose death in unfamiliar environment. Right? People have a higher chance of dying if they're in a new place when they do a drug versus an old place. It's because your body's conditioned. It has a memory, it has some association with the location. Your body produces something, some adaptive sort of response to that, and then the effective dose of a drug is lower than if you're in a new place and your body can't predict it. Right? So it's not a cognitive thinking thing. It's just your body's reaction or conditioning kind of history. And so I think that works with mood, it works with words, it works with all kinds of stuff. If that makes sense. Okay. Sure. Okay. Okay, cool. Oh, yeah. No, thank you. Okay. We had a conversation about hot mics earlier, so I don't want to fall victim.